Hey, what's up? Alright, so this video is about graphing linear equations. It's about graphing lines. Alright, so I'm gonna give some examples here, alright? And I'm gonna try to explain the steps. So, first thing we need to graph a line is we need to graph the Cartesian plane, okay? So, Cartesian plane, the XY plane, is just a system of coordinates that we're gonna use. So, here we go. We have an x-axis right here. We have our y-axis right here. So, the first thing you want to know about graphing a line is that there's a certain form of a linear equation which is very helpful to do so, and that is slope-intercept form. And the way you write that is it's y equals mx plus b. This is called slope-intercept form, alright? And in this form, you have to remember that m is the slope, b is the y-intercept. Okay. So let's say they gave us an equation. All right. Let's say we had an equation that looked like y equals 1/2 x plus 3. Now, the way that I know that this is a linear equation is because it just has a single power of x. This is just x to the 1, okay? So I know that the graph of this equation is going to look like a line. Now, looking at slope-intercept form and looking at this equation, do you see how there's kind of a correspondence between these two equations? So y is y, m is 1/2, x is x, and b is positive 3, right? Okay, so using that information, we can use the numbers that we see here, 1/2, which is the slope, which is m, and 3, which is the y-intercept, which is b, to kind of help us draw a picture of this line. So the first thing you want to do is you want to look at 3. This is where you start. This is the y-intercept. So you say whatever this number is, this is positive 3, so I'm going to put my pin right here. I'm going to put a dot right there. Now, why did I do that? Well, the reason I put a dot on 3 is because this is where I would be if I counted starting from here. This is always where you start. Starting from here, if I counted up 1, 2, 3 on the y-axis, this is going to be my y-intercept. So the reason this is called the y-intercept is because this is the place where it intercepts the y-axis, okay? So you start from 0 and you go 1, 2, 3. You count upward by 3. If this was a negative 3, I would have counted downward, but since it's positive, I counted upward. Okay, so there's a dot. All right, now what do I do with this 1/2? Turns out this 1/2 is the slope of the line. And if you recall, slope equals rise over run. So if I said, in this case, the slope is 1/2. So rise over run is 1/2. So what this means is that I have a rise of 1 and a run of 2. See where I got this 1/2? I got this 1/2 from right here, okay? So the rise is 1 because it's the top number, and the run is the bottom. So rise, what means I put my pin on this dot, and I do rise of 1, positive 1. So I go upward 1. And then I go a run of 2. So I go up 1 over 2. Boom. The reason I went up and right is because this is a positive number, and this is a positive number. So positive 1 means up, negative 1 means down. Positive 2 would mean right, like we did, because this is positive, and negative 2 would mean left. So that's very important. In terms of rise, positive means up, and negative means down. In terms of run, positive means right, and negative means left. Okay, so you got to keep that in mind because, and the reason is because this is the positive direction and this is the negative direction for x, and then for y, the positive direction is up, negative direction is down. So I just want to go over that. Okay, anyways, so we have our 2 dots. Okay, we have our 2 points. Now, we can just simply actually just draw a line between them, and that's how we'll get our equation. So I'm going to draw a line right here. So that's the graph. It's a line. It has a slope of 2 because it's up 1, a slope of 1/2 because it's up 1 over 2, and it has a y-intercept of 3 because 3 is how high it is when it crosses the y-axis. Okay, so that was one example. This was easy because this equation here was already in slope-intercept form. It already matched up to this form when they gave us the equation. What if we had a different sort of situation, though, in which we actually had to use some algebra to modify the equation a little bit and get it into slope-intercept form before we could graph it. That's what I'm going to show you next. Okay, so I'm going to draw another coordinate system, another graph, just so I can not have to try to scrunch things in, because I just wanted to make this clear. So here's our x-axis and our y-axis, all right? So now, suppose that they gave us an equation that looked like this. What if they said, okay, 4x plus 2y equals -10. So the first thing wrong with this equation is that it needs to be in this form. It needs to be in a form that looks like y equals mx plus b. You can say that to yourself over and over. Y equals mx plus b. Y equals mx plus b. You have to memorize this, because this is the only form of the equation in which it makes it easy to graph the line, because you can clearly see what the slope needs to be, and you can clearly see what the y-intercept is going to be. Okay, so what's the first step here to get this into slope-intercept form? Notice, what we're basically trying to do is just get y by itself. We're trying to essentially solve for y. So, in order to get y by itself, I need to get rid of this 4x. Okay, so I'm going to take this 4x, and I'm going to subtract it from both sides. Okay, so I'm going to go subtracting from both sides. This crosses off, so my new equation simply looks like 2y equals -10 minus 4x. Okay, now what I'm going to do is I still have to get rid of this positive 2, because notice, see in slope-intercept form how I just have a single y? I can't have any number multiplying the y, so I have to get rid of it. So I divide by 2, divide by 2, and divide by 2. I'm dividing both sides of the equation by 2. This goes away. Great. Perfect. Now I have a single y. This is going to be a -10 over +2. It's going to give me a -5. And this is going to give me a -4 over +2 is -2x. Okay, final thing I'm going to do is, just for cosmetic reasons, I'm going to switch these two terms around, okay? I'm just going to say y equals -2x minus 5. I didn't do anything, I just changed the order, okay? And the reason I did that is because I just want this to be more, I just want it to be more obvious that it's matching up with slope-intercept form. In fact, I'm going to write that underneath it, so again, so we can see exactly, you can see exactly what this is, right? Whoops, I just messed up. It's supposed to be b. Okay, so notice, y equals mx plus b is corresponding 1-to-1 to y equals -2x minus 5. What that means is that m and -2 go together, and b and -5 go together. So if I were to write this out, m equals -2. b equals -5. So the slope is -2, and the y-intercept is -5. Recall, the first thing I'm going to do is I'm going to take my pen, and I'm going to put it on the y-intercept. So b equals -5. So I'm going to start at the 0. I'm going to start at the origin. I'm going to count downward by 5. 1, 2, 3, 4, 5. And I'm going to dot. The reason I counted downward is because this was a -5. Remember last time on the first one it was positive, I counted upward. This one it's negative, so I'm counting downward. Okay, so this is my y-intercept. I know that this particular point is actually going to be a point on the equation, or on the line, okay? So now the question is, though, is where do I go from here, right? Well, that depends on the slope. Recall that our slope is equal to -2. All right, now if I were going to rewrite -2 in a more in a better way to where I could see what the slope is, I would rewrite it like this. Instead of -2, I'm just going to think of this as -2 over 1, right? Because anything over 1 is itself. But now the reason this is important is because now I can clearly see that this is rise over run, which means I have a rise of -2 and a run of +1. So if you remember, if I count downward by 2 and rightward by 1, because remember, down means negative and up means positive. In terms of run, right means positive and left means negative. So -2 over 1 means I count downward by 2, rightward by 1. So downward by 2, rightward by 1. I'm going to put a dot right here. So cool. So now I have 2 dots, and so all I do to graph the line is simply draw a line to connect the two. And it's going to look like this. There we go. So that's the graph of this line. So I'm going to do a quick overview, okay? First thing we did is we got an equation that was already in slope-intercept form. So all we had to do is we just had to look at 1/2 and realize that it was the slope. we had to look at 3. We realized that was the y-intercept. So we put the dot here. We put the dot on 3. We said rise over run is 1 over 2. So we went up 1 over 2, draw the 2 dots, draw the line. Okay, cool. The second example that I gave you was an equation that was not already in slope-intercept form. See, it didn't have a y by itself. It was all jumbled up. So what I had to do is I had to do a little bit of rearranging first in order to get it to where it looked like this nice little y equals mx plus b. So we got it into that form finally. It turned out that it was y equals negative 2x minus 5. Then I looked again, just like I did the first time. I looked at the correspondence between m and negative 2 and b and negative 5, and so that's why I could find out, I could identify by the form of this equation what m and negative 2 was, or excuse me, what m was and what b was. Okay, then I use that information, starting with the fact that I know that this point right here is a point in the line because this is the y-intercept, because it's negative 5, so I counted 5 downward. And then all I did from here was I just looked at the slope. I realized that negative 2 is the same as negative 2 over 1. Negative 2 is the rise, positive 1 is the run, so I went down 2 over 1, I got 2 points, and I drew the line.